pick through the videos here for the examples that you guys were given. So this investigation of environmental causes of disease, we got this data collected on a mortality rate for males in 61 large towns in England and Wales. Water hardness was recorded in the drinking water. So we noticed whether the town was north or south of Derby, so a town there. So is there a significant difference in the mortality rates in the two regions? So here's the basic information they give you. Notice they did say standard deviation of the sample, which puts us right on track for a two-sample t-test. Um, we'll draw our degrees of freedom down here in just a minute. Before we move forward, I'm just going to come up here. Population 1 is going to be from the north of Derby. Population 2 will be from the south of Derby. So the original hypothesis will be that the two are equal, and the alternative, again, is there a significant difference? In other words, does mu1 not equal mu2? So the trick for us here, if we want to remember, if we move mu2 to one side, in other words, if there is no difference when we subtract those two population averages, they should be equal. If there is a significant difference, when I subtract those two, something should not equal 0. It's going to be a t value. I can go ahead and start filling this in. 1631.59 minus 1388.85. Remember, mu1 minus mu2 is 0. And then we have over the standard deviation of 138.47 squared over 34 plus 151.114 squared over 27. We're going to let the calculator do the work here in just a minute. The conditions, are they both random? Data notes, whether it's in north or south. Actually, go back and look. Investigations, so I don't see anything about randomness unless I'm missing it. So we'll just have to assume they're both random. N1 is definitely greater than 30. N2, we're going to say it's big enough. It's greater than 25, so we're going to call it big enough. And then the two groups independent of each other. So there's my conditions. Again, we just want to be familiar with those as we keep working our way through. Now, we're going to let the calculator take it from there. I'll go ahead. I don't see anything besides an alpha level of 0.05. So go ahead, let's type all this fun stuff into our calculator. Make sure we selected a two-sample t-test. Over to the stats, and then just fill that in. I'm going to pause this for just a moment. You might want to as well, because I'm just going to come back and kind of tell you what I'm getting from my calculator if you want time to type it in yourself. Keep in mind, we're not going to pull the data. We get a t-value of 6.47. The p-value equals, it looks like a 3.15, but remember it's 3.15 times 10 to the negative 8th. Which is essentially 0. So 0 is definitely less than 0.05, which means we're going to reject the null, which means evidence suggests a significant difference in mortality rates of towns north versus south of Derby. And the one thing you got to make sure you go back and you do fill in this one gap with that degrees of freedom. The calculator told you is 53.5 degrees of freedom. So don't forget to leave or put that piece in there. Now, number 2, you're going to take a second and put that data into the calculator. Once you've got it into the calculator, what you should see in just a minute, I'll pull it up there, but again, we're not given any kind of population standard deviation. So again, we've got a two-sample t-test. And once you've got all that data into the calculator, it'll kick back to you pretty quickly. Just be very, very careful putting things into the calculator. Here we'll go population 1 is children's cereals, population 2. Take a second to do this step, because that way a grader, a reader, can see easily which group is which, so you can know too if positive, negative, whatever we're looking for. One thing that we want to look very, very closely at, see if children's cereals have more sugar. So here, the null hypothesis, mu1 equals mu2, versus the alternative, mu1, which is children's cereals, is it higher than adult cereals? If you switch these populations, you'd have a different direction for that inequality. So that's one of the important reasons that we want to make sure that we label the population so it's easy for people to follow. I'll do my conditions over here. So are they both random? Using data, I don't see that. So again, we're going to assume. It looks like we got pretty large samples on both sides, but we could also easily check for normality once we put that in the calculator, just by checking a quick histogram. And then the two groups are independent of each other. Right? Kids cereals should not affect the sugar content of adult cereals and vice versa. So I don't know what any of this stuff is, except I do know this is -0. And I know this is going to end up being plus. And I got a couple squares in here. I have no clue what x bar 1 and x bar 2 are. I have no idea what S1 and S2 are. I'm going to let the calculator do all that work. Just kind of set stuff up. They did give me an alpha level, because 0.10. And then I'll go ahead and I'll put my p-value. I'm basically just setting myself up so I can roll through the calculator. So if you put all that stuff into the calculator carefully, here's what should kick back to you: a t-score of 17.8. We're pretty far off the mean here. We're 17 standard deviations away. That's what that value is telling you. Let me go back. I don't know why I just got rid of that. Put my two sample t-test. Now, I did run it initially in another calculator, and then I just transferred my data over there. So the p-value, it looks large at first, 1.04. Let me warn you, I don't know, maybe if your name's Abby, or that's just a random name that I thought of, to go all the way down here to the end. That's times 10 to the negative 21st, which means there's 20 zeros before the first one. So essentially, our p-value is 0. Is there a chance we could get this situation? Sure. Is it incredibly small? Absolutely. So we're essentially looking at a p-value of 0. So t-score 17.8. So we're 17.8 standard deviations away. P-value is essentially 0. So 0 is definitely less than 0.10, which means we'll reject the null. And so we can fill in here. So evidence suggests and here we actually claimed a difference, right? We claim that children's cereals, shockingly, have more sugar than that on average. Kids cereals, and we don't just have to say more. We can say have significantly more sugar than adult cereals. And now it's just a matter of filling in all the gaps. So look back over at your calculator. X bar 1, 46.8 minus 10.2. So 46.8 minus 10.2. The degrees of freedom, I'm just going to kind of, the degrees of freedom, 42.8. Fill that gap in. Go back, we need S1 and S2. So we have 6.4, 7.6, so 6.4 squared, 7.6 squared. If you'd like more decimals, by all means do it. And we have 19 and 28. So here we go. Actually, neither one of those were large enough, so we would have actually had to check normality. Easy thing to do if you just go to the histogram. On the back page, so Consumer Report articles describe the content of these. We've talked about these hot dogs already, meat and beef. They've given us a 90% confidence interval. So the endpoints of this confidence interval are negative numbers. What does this indicate? Well, for us right now, it indicates a significant difference in mean fat content, right? Beyond this, because the whole thing's negative, well, which one of those would have to be bigger to make this negative? It'd be the second number. So because the entire interval is negative, it indicates, excuse me, that on average, beef hot dogs have significantly more calories than a delicious meat hot dog. All right. So the fact that it does not contain 0, that indicates that there is a significant difference. We kind of just said that. Significant difference in average number of calories. Between the two types of hot dogs. So I'll throw some context in there. Make sure we're always keeping context in mind. All right. And so part C, which of the following statements are true? If I eat meat hot dogs instead of beef, there's a 90%. That's not it. Really, we're looking for what is the interpretation of that 90%. I'm 90% confident that meat hot dogs average 1.4 to 6.5 less grams. So again, which one would have less amount of calories? Was it calories or fat? Whatever it happened to be. Oh, fat content. Oops. So I didn't read carefully. So let me go back and fix A and B. Apologies to those of you that were reading carefully and looking to get me. Haha, I win. It looks like 3 could be right. We're not making a comment about 90% of the hot dogs. We're 90% confident. So it does look like meat hot dogs had less, and I believe 3 is it. But let me go through and make sure 4 and 5. If I were to get more samples, 90% of the time meat hot dogs would average. Well, this isn't true because this makes the interval get stuck. Look up at the front of the room or at the side of the room. Intervals are never stuck. This makes it seem like 90% of the intervals will have the exact same endpoints. That's not true. And then if I test as many samples, I'd expect about 90% of the confidence intervals to include the true difference. This is a true statement. 5 is a true statement because 90% of the time, the intervals are going to change, but 90% of them will contain the true difference. So it looks like 3 and 5 are the two that are actually legit.